This video is part 1 of Chapter 6, Thinking and Intelligence for PSY 110S, the Psychological Sciences. In this chapter, you're going to be learning about how psychologists, and this is a combination of psychologists from different areas of the discipline, but a lot of this work is done by cognitive psychologists or cognitive scientists, not exclusively from the discipline of psychology. In fact, there are even researchers coming from behavioral economics who have contributed to some of this work. As we get into the part of the chapter on intelligence, developmental psychology has also been involved, as well as the more mathematically leaning areas of psychometrics. We need to start by having a working definition of what we mean when we use the word thinking. Now, thinking is a word that you use all the time in your everyday life. As scientists, we need to have a more concrete, agreed upon way of talking about what it is that people are doing when they're thinking. What you'll see in this definition is sort of a leaning in the direction of a specific kind of thinking. And this thinking that is seen as the way in which humans navigate their lives by using that big, powerful brain that they have. So cognitive psychologists, cognitive scientists think of thinking as dealing with information, making sense of it. The word processing makes it sound very computer-like. Processing in cognition involves converting a lot of information from physical stimuli into neural events that can then be made sense of. So, and then the other side of it is we pull in information from our social experiences, from our environment, and again, we have to process it. And a lot of that processing is integrating new information with old information. In order to do something with that information. Often that involves problem solving, using logic, using reasoning, using past experience to make decisions, and to render judgments. Those judgments can be about ourselves, about our situations, about other people, about the world in general. Pretty much anything that your brain works on is thinking. Now, problem solving, when we refer to that concept in cognitive psychology, problems are defined as contexts where there's a goal, there's something you want to accomplish, but it's not clear how to get to that goal. And that's what makes it a problem. So you can see what solution you want to come to eventually, but you may not have the solution yet for how to get that problem resolved. There are many different kinds of problems that cognitive psychologists study. Some problems are very, very well defined. There's a straightforward answer. There's a clear, definable goal. So your authors give the example of playing Scrabble. You have to take the random letters that are on your side and form words in order to earn points. That's a well-defined problem. There are also ill-defined problems. Ill-defined problems don't have any sort of clear defined goal state or a start point or even practiced or familiar ways of getting to the goal. People tend to find ill-defined problems annoying, stressful, even anxiety-provoking. Some people get angry when they're handed an ill-defined task and they're expected to achieve something, but that something is undefined. Well-defined problems tend to involve, pretty clear procedures that if you follow them, you're going to get there. Ill-defined problems, not so much. So it's not that everybody hates them. People who like mysteries and solving ill-defined problems they enjoy it and find it a great deal of fun. Now, there are lots of blocks that humans run into when trying to solve problems. This whole conversation that we're going to have next kind of shows the difference between human cognition and machines that solve problems using algorithms. So when we face blocks to problems, sometimes it's because we're having difficulty interpreting what the problem really is. Then there can be blocks in our efforts to try and solve the problem. Perhaps we're perceiving limitations where those limitations don't exist. We don't have familiarity with the steps or with what kind of tools might be useful in helping us to solve the problem. For many problems, the actual route to achieving the goal is somehow blocked. And that means you may have multiple problems on the way to getting to a solution. And breaking those down into steps can be one of the challenges that we face as a block to problem solving. Now, your authors give you an example of a stimulus that's often used in problem-solving studies, where this exposes basically some of the blocks that we impose on ourselves. And for cognitive scientists, they're kind of looking at this as a way of showing what are some of our blind spots as we attempt to solve problems based on instructions we've been given. Now, part of this has to do with the tendency in human thinking to be gestaltist, meaning that we tend to impose rules over things that we see and perceive in our environment. And those rules, those schemas that we impose on things that we're experiencing, can basically cause blocks to our own ability to solve problems. So your authors present you with the 9-dot problem. The instructions are to connect the 9 dots using 4 straight lines without lifting your pen or pencil from the paper. Now, many of you have probably done a problem like this one, and you may even know what the solution is. But what you should notice is, your initial examination. Remember back to the sensation and perception chapter where we talked about how we perceive lines, boundaries, even when they don't really exist. What you have here, you're looking at this image, it appears to be a square with corners and sides defined by the dots. In reality, it's just 9 dots. The fact that we impose a pattern over it that has meaning to us, that creates a problem-solving block for many people on their initial attempts to solve the problem. So as Griggs and Jackson note, you have to break the boundaries that are imposed by your perceptual systems. So instead of seeing this as a square with corners and sides defined by the dots, you have to literally ignore the square, which many people find very difficult to do. In the left-hand image, another limitation becomes clear. Even though it's a successful solution to the problem, you're still piercing all of the circles in the center. We have a human tendency to see circles as something that should be bisected, not pierced at odd angles. So the solution on the right includes a change in the structure where you're not piercing all of the circles in the center, and that really changes the nature of the solution. Another kind of block that we face is an interpretation block, where we're not understanding exactly how to interpret the cause of the issues that we're trying to resolve. So I included this picture because when we look at a tennis ball, we don't think of a tennis ball as something that would be useful for anything other than tennis or playing with your dog, assuming you have a dog that fetches. However, and I shocked my son-in-law once by making a suggestion. They had washed a very, very large comforter, and they were talking about how annoying it was that the the stuffing in the comforter would get kind of balled up in different locations after they put it through the dryer. And I said, well, do you have any tennis balls? And at first he looked at me like I kind of lost my mind and maybe fell on my head. I said, no, I'm serious. Do you have some tennis balls? All you need to do is put tennis balls in the dryer with your comforter, and it will, in fact, prevent the kind of balling up that you're talking about. And he was like, no way. And literally, that is how he talks. No way. But then he got a whole brand new tube of tennis balls, dumped them in the dryer, and it worked. So what's happening there is it's a fixation. We see objects as having very specific purposes, and we find it sometimes difficult to break out of the original purpose of the object. Like putting tennis balls in the dryer just seems to make utterly no sense whatsoever, but it works. Someone figured out that it works, and yeah, you just have to think outside of that limitation. Functional fixedness, and I'm going to show you a video here in a second for how this kind of task is run in the laboratory or in experiments. Functional fixedness, like with the tennis balls, it means that you're seeing an object and it has a particular purpose, and we have difficulty seeing it having a purpose outside of that. So balls are to play games with. Balls are to throw to pets. They aren't a laundry tool. So that's an example of functional fixedness. It tends to limit our ability to solve problems that require that you think about objects in alternative ways, in new and different ways. So solutions often involve thinking about the qualities of an object. Like a tennis ball is fairly rigid, but it's also fuzzy. The rigidity helps in the dryer because it basically beats the blanket up. The fuzziness helps to spread the balls out, and they kind of stick to the cloth in the dryer, and that helps to soften fabrics, but it also helps to keep stuffing from balling up in specific locations. So here's an example of how functional fixedness tests are done.
You can take this test right from your living room.
This is a simple game, really. All you have to do is tie two ropes together. The problem is, these two ropes don't easily reach each other. So that's going to require you to come up with a creative solution. You have the chair, a paint can, and a pair of pliers that you can use to solve this problem.
Take a second and consider what you would do to tie this 5-foot rope to this 4-foot rope. Keep trying as these college students also take on the challenge.
You understand what you have to do? I gotcha. Tie the ropes together?
Yes.
You can't reach both ropes from the floor, but simply standing on the chair won't help. You're going to have to get creative.
I'm going to tie the chair.
Okay.
Seem impossible? We assure you, it can be done.
Yes, it's going to work.
Do you feel like giving up too? Well, before you do, let's find out what might be standing in your way.
When you're trying to think of uses for the objects that are in the room, you have a hard time thinking of a use that you haven't encountered in your lifetime.
You're not born knowing what a paint can is, but over time, you form associations, such as what a paint can looks like and how it works. Object association is an activity that takes place in a region of the temporal lobe.
If we can prime people to think of a can of paint in a completely different way, it can really help us solve the problem instantly.
So, how does this apply to the ropes challenge and the objects provided? First, you have to add weight to one rope to create a pendulum. What can you use for weight? Here's where that creative thinking comes in handy.
You've gotten very close. You're very close.
Swing the paint can pendulum. Then, while holding onto the other rope, stand on the chair and catch the pendulum as it swings in your direction. With the ends of the ropes now in close proximity, you can release the paint can and tie the ropes.
Yay! Okay. You got it. Yeah.
Did it.
Good job.
That was not easy.
Have you ever used a paint can as a pendulum before?
No, I have not.
Is it the first time?
Yes, it is.
To get in the gym. I did that. Yes.
Congratulations on completing the Total Mental Fitness Challenge. The two ropes problem required your concentration to slow down and take in the details, and your mental flexibility to stretch and find a creative solution.
So that's a real common task. The ropes task is commonly used in cognitive science as a way of demonstrating our tendency to be kind of trapped in functional fixedness. I often wonder if people in certain professions, like engineering and don't laugh. Okay, you can laugh if you want. Farming. Being a farmer, you have to often, on a moment, in a moment's notice, fix a piece of equipment even though you don't have tools or parts available. So you often have to look around your environment and find things that will approximate it or that will meet very specific short-term goals for getting something to work. There are also strategy blocks, and this can include kind of getting stuck in using strategies that, despite the fact that they haven't worked, people tend to be really restricted into thinking that the strategy will eventually work at some point. It's kind of like sitting at a gambling machine, at a slot machine, and thinking, if I just use the strategy for long enough, the strategy will play out. This is what's referred to as a mental set. So if we've been successful using a strategy in the past, we will tend to latch onto it and just persist in using that strategy, even when there are better strategies for achieving the same problem later, or more efficient strategies for solving the problem. In order to break the strategy block, you have to go back to that interpretation issue. You have to find additional ways of interpreting the problem that suggest a more immediate solution. That's referred to as an insight solution when we're looking at new approaches. Now, what tends to get in the way is our memory and our comfort with already learned, previously used strategies. So breaking out of these mental sets can often be very difficult for us. One of the methods used to test these kinds of barriers to problem solving is by using what are called insight problems. So sometimes when you're looking for a new way to solve a problem, you can all of a sudden have an idea pop into your head that's referred to as an insight experience. So this is a situation where you go, aha, oh, I get it, I've got it, and the solution just comes to you. So in tasks like this one, the equation is shown here. So these are our Roman numerals, where you have 4 equals 3 minus 1. So it's currently incorrect. To create the correct equation, you can only move one matchstick, but you can't take it away. So what are you going to do in order to solve the problem? And I'll give you a second to think about that. If you've read your chapter, you already know what the solution is. So what you can do to resolve the problem is you can simply move one of the matchsticks from the first equal sign and then create an equal sign on the other side of the equation, and that makes it correct. One of the difficulties that people have with the matchstick problem is kind of breaking out of part of it is the Roman numeral part. We're not as familiar with it and we can get confused by it. The other part of it is trying to keep the structure of the mathematical equation, like not feeling like the equal sign is inviolate, that you shouldn't change it. So people tend to drift to changing the numbers, but not the signs that are available to them. So how do we overcome these problem-solving blocks? And these recommendations may seem kind of silly, But one of the things that you can do is to try and break up your thinking, which will force you to call into question your current interpretations of the problem that is facing you, and identify the constraints in your thinking. So if you go back to the 9-dot problem, reminding yourself of the Gestalt tendencies in our perceptions visually. Am I imposing boundaries where they're not necessary? Based on the rules of the game, nothing says you can't go out of these imagined boundaries. So asking yourself, is my interpretation being unreasonably, unnecessarily constrained? Can I use objects in novel ways to solve problems? And then, do I need a brand new type of solution? Now, in the next section, we're going to talk about some other ways in which humans organize thinking about their world, and ways in which they solve problems.